Hi, welcome to our workshop, Self-Service Machine Learning with Amazon Redshift. My name is Phil Bates, and I'm a Senior Analytics Specialist Solution Architect. I'm joined by Satish Sathya, who is a Senior Database Engineer, DBS Redshift. Here is our agenda today for the workshop. First, we'll do a brief overview of Redshift and Redshift ML. Then we'll talk about the use cases that we'll be doing in the workshop. And then we'll jump over and do our demos and labs, and you'll be able to follow along. With Amazon Redshift, we enable a lake approach to analytics, which allows you to use Redshift as your primary data store and combine data with other data stores without leaving your data warehouse. This can reduce the need to build additional ETL pipelines that can take days or even weeks. Using Redshift Spectrum, you can query data from the S3 data lake. Data can be queried in common open file formats such as Parquet, JSON, ORC, or Avro. Redshift also integrates with AWS Lake Formation so you can provide fine-grained access control. In addition, you can unload your data into S3 using the export command in data formats such as Apache Parquet. And finally, the part that we're going to be focusing on today is how we integrate with ML and analytics services. You can use Amazon Redshift to integrate with SageMaker. Amazon Redshift ML makes it easy for data analysts and database developers to create, train, and apply machine learning models using familiar SQL commands in Amazon Redshift data warehouses. With Redshift ML, you can take advantage of Amazon SageMaker, a fully managed machine learning service, without having to learn new tools or languages. Simply use familiar SQL statements to create and train Amazon SageMaker machine learning models using your Redshift data, and then use these models to make predictions. When you run the SQL command to create the model, Amazon Redshift ML securely exports the specified data from Amazon Redshift to Amazon S3 and calls SageMaker Autopilot to automatically prepare the data, select the appropriate pre-built algorithm, and apply the algorithm for model training. Amazon Redshift ML handles all the interactions between Amazon Redshift, S3, and SageMaker, abstracting the steps involved in training and compilation. Finally, after the model is trained, Amazon Redshift makes it available as a SQL function in your Amazon Redshift data warehouse. You can use supervised training for advanced analytics using Redshift ML. Some of the common ML use cases we see are customer churn, predicting if a sales will lead to a close, or fraud detection. And we'll be covering a couple of these in our labs today. For our workshops, we're going to be taking a persona-based use case approach. First of all, we'll look at it from the lens of a data analyst. We'll be doing a binary classification use case using Redshift AutoML. What that means is we will not be specifying any problem types or objectives. Then, for the advanced data analyst, we'll be doing regression where we do specify the problem type and the objective. Next, we'll take on the persona of a citizen data scientist, creating an XGBoost model. Then finally, we'll do an advanced data scientist persona using the bring your own model functionality, where we will create a model in SageMaker using the random cut forest algorithm, and then we'll show you how to do remote inference in Redshift to do anomaly detection. For our demos, we're going to be leveraging a GitHub repository that you can see here. It's under AWS samples, Amazon Redshift ML getting started. We also have a couple of other links that may be of interest to you so that you can see how to do data API with Redshift and also build an event-driven application using AWS Lambda and the Amazon Redshift data API. So now let's get started and go do our labs. Here is our GitHub repository that we were mentioning earlier. You'll be able to follow along with us by using the use cases that are in here. As you can see, we have several use cases that we can look at. As I mentioned, we'll be using the binary classification, the regression, the bring your own model, and we'll also be looking at how to do XGBoost. Now that we have our GitHub repository and you can take a look at that, let's go over to the AWS console and log into SageMaker, and we'll start doing our use cases with our notebooks. First thing to do is we'll go to the AWS Management Console and we'll choose Amazon SageMaker. Click on Notebook and then Notebook Instances. As you can see, I have a notebook here called Demo. I'm going to select that and then I'm going to open Jupyter. So you can see I have quite a few notebooks here, but we're going to start with the binary classification notebook. The binary classification notebook was uploaded from the repository on GitHub that you saw earlier. For this use case, we're looking at customer churn. We have a customer data set of an example telco customer that's been attributed to the University of California Irvine repository machine learning datasets. We have modified this to work with Amazon Redshift ML. The first thing that we're going to do here is give a couple of parameters. We need to tell it the Redshift endpoint and our user. So we'll run that. And then the next thing we're going to do is create a run SQL function using the Redshift Data API. This will allow us to get SQL query output directly into Pandas data frame. The Amazon Redshift Data API enables you to painlessly access data from Amazon Redshift with all types of traditional, cloud-native, and containerized serverless web-based applications. The Data API simplifies access to Amazon Redshift by eliminating the need to configure drivers and manage database connections. So now let's execute this to set up our function. We select the cell and we'll hit run. Optionally, we can create users and grant permissions. For this, I have already pre-created the users and granted the appropriate permissions, but you can see here the notebook has an example of the SQL statements you need to do that if you need that. The next thing to do is to do the data preparation. As you can see here, we have a variable in our cell called setup script that's going to put in everything we need. We will drop the table if it exists, and then we will create the table, and then we will copy and load the data from a public S3 bucket. As you can see, this has typical customer activity data that you would expect. Things such as the account length, the area code, what types of plans the customer is enrolled in. We also have a record date, which is equal to the monthly billing date, and we have a churn value. That tells us if the customer has churned or is still active. Since I have already run this script previously and created the table, I will skip that, but you can use this to create this in your own environment later. Once we have defined our setup script variable, you execute it down by, in this next cell, by executing this. You would simply highlight this and hit run, and that will execute the SQL statement that you've previously populated. Now, I have another example of granting permissions for the model. You can grant select on the customer activity to your user and also grant the create and usage on the schema as well. We've already previously done that, so we can skip that step. Now, we'll show you how that you can use the data frame to run a select statement. What we're going to do now is select the first 10 rows from our customer activity table. As you can see here, we have our data, and that's interesting. You can take a look at some of the samples that you have, the typical data that you would expect from this use case. Now, let me show you another interesting thing you can do with the Pandas data frame. We can do what we call df describe, and that provides some interesting statistics about the file or our data that we're using. You can see the counts of the various attributes, along with how many unique values you have, what the top values are, and the frequency that they have. Now that we have our data loaded and ready, it's time to run our create model statement. So as you can see here, this create model is very simple. We simply say create model and give the name of the model that we want to create. Now, I have previously created a model called customer churn model. So for this example, I'm going to give it a different name so I can demonstrate to you what it looks like while you are training a model. But once you have your create model command here, you simply wrap that around your select statement. Your select statement contains the data or the inputs that you want as part of your model training. So all these values are what we call inputs. And then you have a target that you give it. In this case, we're trying to determine if customers are going to churn or not. So our target is churn. And if you notice, the value that you have as your target also needs to be in your select statement as well. So here we are, we're selecting from our customer activity table that we have previously loaded. As you can see, we are not giving any other inputs to the model, such as the objective. We give it a name, and the name is whatever you want that to be. That will be once the model is created and trained. This function will be in Redshift available for you to use for your prediction queries. The only other things that you need to provide is an IAM role with the proper permissions, and then an S3 bucket. The S3 bucket is where the data will be residing as it does the transition from Redshift to SageMaker ML. So let's run our create model statement and see what we have. So this model, once you execute that, it will run asynchronously in the background. So it is finished running. The Redshift part is done, and we'll check the status so you can see what it looks like now. I need to change the name here because that's my previous model that I created. So let's see what this new model is doing. So what you want to see is the model state. So that is training. So at this point in time, everything is being run in SageMaker. This will take some time to run, and you can keep checking later. Once the model is done, this will change to ready, and I'll show you that here in a moment. So I have already created, like I said, the previous model. So let's take a look at evaluating the performance of our model. So to do that, we're going to simply select some data. In this case, I decided that we want to look at the account ID, which is the area code and the phone number. We're going to select that. And we want to select the current churn value that exists. And now we're going to call the function that got created and sent back by SageMaker. When we call the function, we use the same parameters that we used in our create model statement. And then I'm going to call this value predicted. And that way I can compare what our model came with versus the actual value of churn. And I'm looking at the same data set that was part of our training set. I'm looking at data that's less than 2020-0901. So as you see, my first query, I'm looking to see the where the actual value matches the predicted value. We matched on 2,478 rows. Now let's see how many don't match. We have 420 rows where we don't match. So our accuracy rate is around 80%. Now let's also look at a show model for the previously created model that we did earlier. This, you can see the model state is ready. Our validation says binary F beta, which is default binary, it's F1. That means it could be one of two values. In this case, it's true or false. Customer will churn or not. And that is our F1 score. Now that we've looked at that, it's time to make a prediction. So we're going to invoke our model for inference. Again, very similar to the query that we ran earlier just now to check for accuracy. We're going to select our account ID, and then we're going to call our function, passing in the same values that we had in the create model statement. This time, we're going to say, let's look and see what customers in area code 408 are likely to churn. In this case, we've changed the record date. We're looking for everything that's greater than or equal to 2020-09-01. This is new data that's come in, so it was not part of our training set. As you can see, we have 97 customers that are predicted to churn. So now this data, the customer service team can take this data and reach out proactively to those customers and try to assist them with their needs and ensure that they don't churn. Now, I've got a couple of other optional things here to show you that you might be useful for in the future. If you have different reporting areas, like you want to set up a group for marketing analysts and you want them to be able to just run the predictions or the inferences, you can do a grant execute on your model function to a group. Also, there are some cost control that you can put into place for your models. So for example, if your select query of your create model statement produces 10,000 records for training, and each record has 5 columns, you would have about 50,000 records. So you can control, or 50,000 cells. You can control the training cost by setting the max cells. Again, you simply add that as another uh, value down here in your create model statement. You give it the max cells. So now you can see how easy it is to create a model and do binary classification. Now we're going to go show you how to do a regression use case. So for regression, I've got another notebook that I've downloaded here as well from the same GitHub repository. Let me find it here. There we go. So in this post, we are going to build a regression model that predicts the number of people that may use the City of Toronto's bike share service at any given hour of a day. The model accounts for various aspects, including holidays, weather conditions. Because we need to predict a numerical outcome, we're going to create a regression model. So to prepare the data for this model, we have populated 3 tables. There's a ridership table that represents the bike share Toronto rideshare data for 2017 and 18. And there's weather data, which is the Government of Canada historical data for 2017 and 18. Also, we've got a holiday table, which is the historical holidays by the University of Waterloo. Again, very similar to what we did in the previous uh, demo. We set up some variables, our endpoint and our user. We also are going to specify a Redshift IAM role and an S3 bucket. And like we did earlier, we're also going to set up a run SQL function so that we can use the Redshift Data API to get the SQL query output directly into the Pandas data frame. As you can see, here are the data that we were talking about earlier. This includes the ridership data and the weather data and the holiday data. We did create a simple view called ridership to perform a few transformations. We wanted to transfer all the date and times to be the local time zone. Also, we discarded trips with a duration of under 60 seconds, and we also trips that are longer than a day. We also aggregated the data to an hourly basis rather than a minute level granularity to get better generalization. As you can see, we've included all the create table statements here for you and all the copy commands that you can use from public S3 buckets to set your data up for you. And we also have created the ridership view here for you that does the transformations we were talking about. We've already pre-created this data, so I won't run this step here, but you can see how that works. And again, to execute that step and actually load the data and everything, you will execute this command here. Again, let's sample our data as we did earlier. We'll select the first 10 records from our trip data table. And as you can see, we have that trip count and by time. Now, we're going to do the describe function again to see the statistics about our data. So we can see we have the number of count and the uniqueness values, the top values, and the frequency. Another nice thing that you can do with the Jupyter notebooks and the data frames is you can plot. So let's take a look at visualizing this data with a histogram. Now we have a histogram of our trip counts. Now let's look at it in a scatter plot view. So to do this and make it easier to visualize, we're actually going to divide the trip count by 100 and look at the trip hours to be able to get a nice scatter plot. There, now you see some interesting characteristics of the data. You can see when the peak ride shares are, and you can see there's a very big peak here on this day. So that's going to be something to take a look at, but you get the idea that you can see that there's a lot of variations in terms of um, the bike rides. So now we're going to run our create model statement to create the model. In this case, again, very similar to before, we're creating our model. I'm going to call it predict rental count 2 as I previously created a model called predict rental count. And again, decided to input these various inputs, such as the trip count and trip hour and trip day. Also wanted to look at things such as the temperature and so forth, and the holidays, because these can be contributors, to the spikes that we might see in the number of rides or the number of rentals. So here we are targeting. Our target is our trip count, and that's our function. And the one thing that's different that you'll see in this create model statement from the previous one is that we're actually specifying the problem type, which is regression. And for regression, typical accuracy metrics are the mean square error and root mean square error, which measures the distance between the predicted numeric target and the actual numeric answer, also known as the ground truth. So we're specifying MSE here as our objective. So let's execute our create model statement here. Now that that's run, let's do a show model. And again, I need to change this to look at the predict rental count 2, which is the model we just created. Now that our model is submitted, let's do a show model to see the status. Here you can see our model name is the predict rental count 2, and this one is in the training state. And you also see where the problem type and objective are regression and is MSE as we specified. So let's run a prediction and compare the actual versus the predicted from the model that was previously created. We're going to select the trip time, the actual count, and the predicted count, and then calculate the difference. So simply what you see here is to do that, we select those values, and then we call our function that came from our create model statement, passing in those attributes. And we'll look at the first 5 records. Now you can see the output and see our predicted count of bike rentals versus the actual bike rentals by hour and see the differences. So now you can see how easy it is to do a regression model using Amazon Redshift ML. Now I'm going to turn it over to Satish, who's going to go through XGBoost and bring your own model remote inference.
Thanks, Phil. My name is Satish Satya. I'm a senior database engineer with Redshift Engineering. Next part of the workshop, so we're going to focus on the third persona, which is a citizen data scientist. The previous two personas we saw was a data analyst who's a named machine learning user. And the second user is an advanced data analyst who can specify some options for the create model in Redshift ML. The third one is an advanced data scientist who knows more about the data and the patterns in the data. So he's going to provide more advanced app options to the create model statement in Redshift ML. For this, we'll be using the same GitHub repository that we used the previous content of the workshop. And the algorithm that we'll be using is called the XGBoost algorithm, which stands for extreme gradient boosting. Is an optimized open source implementation of the gradient boosted trees algorithm. XGBoost is designed from ground up to handle many data set problems in a highly efficient, flexible, and portable way. XGBoost algorithm can be used for regression, binary classification, multi-class classification, and ranking problems. For our use case, so we are going to use the banknote authentication dataset, which is a classic binary classification problem. And we got this dataset from the University of California Irvine machine learning dataset. So XGBoost algorithm in this case will predict whether a banknote specimen is genuine or forged. For this, it's going to use the spectral features of the banknote like variance, skewness, kurtosis, and entropy. So let me go back to the notebook here. Before that, let me show you how the data, the input data looks like. So these are the variance, skewness, like I mentioned, variance, skewness, kurtosis, and the entropy are the spectral features from the banknote specimen. And class is the column that the Redshift ML is going to predict. So 0 means it's a genuine banknote, while 1 means it's a forged banknote. This is how the input dataset looks like. Let me go back to the notebook. So again, so we're going to set the initial Redshift parameters that we want to connect the Redshift cluster. So I'm going to run that. So because, just so you know, right, because we are using the Redshift ML GitHub repository, so we are using the notebook. So you can choose to use your own SQL client to run all these commands. So this cell creates the Redshift connection or the run SQL function, which can execute SQL commands against the Redshift cluster. Here is the data preparation step. So we have divided the banknote authentication dataset into two pieces, two tables. One is for training and one is for test. So we will use the train dataset as the input for the create model. I've already created this table in the database already, and I've already loaded the sample dataset, like as you can see here, using the copy statement. So when you run this cell, run SQL, it's going to create the tables for you and also will load the data for you if you want to follow along. Let's go into the create model statement here. As you can see, it's a little different from the previous create model statement that Phil ran. The first difference you'll see here is the auto is set to off here, which means so we are not going to use the auto mode, but we are going to provide more options because this is the advanced data scientist user persona. First of all, we're going to provide the model type, which in this case is XGBoost. And the objective for this XGBoost is a binary logistic because it's a binary classification problem. Pre-processes is the next new option that we see here. This can be used if you want to provide some some characteristics that you want to transform the input data, which in our case is none. So we are going to set that to none. And the next one is the hyperparameters, which is very specific to the algorithm that we use. In this case, we are using num round, which means the number of times you want to do the training, which is set to 100. Again, the S3 bucket is set to the previous S3 bucket that we use. This is where we stage the training data set. And also the the Amazon SageMaker will write the intermediate artifacts to this S3 bucket. Let's go ahead and create this model. I'm going to give it a different name because I already pre-created the model and it will take some time to create for the create model to finish. So I'm going to give it a different name and also a different name for the function as well. Let me go ahead and run this. Sorry, I have to use a different name because I already have a create model with the same name. So I'm going to create it one here. Okay, while this is running, so we can also run a show model command to see the stage where your create model is. So as you can see, this model state is in training state because we just started the create model, and the query that was used for the training data set and the parameters that we use. We know we use the XGBoost as the model name. And the function that is going to be deployed is function model bank authentication XGBoost binary 3. Again, as you can see, we have some new options here showing up, which is the hyperparameters that we passed, the number of rounds, and the objective. So we can also, because I already pre-created the model, we can also run a show model on the previously created model, which is going to show a different output because the model state is in the ready state because this model was already pre-created. Okay, now that we're going to use the pre-built model, let's go ahead and get the accuracy of the model that was created. So as you can see, I'm using the function that was created from the pre-built model, and I'm going to pass the same columns that were passed to the create model, which is in this case all the columns, and I'm going to calculate the accuracy. So the accuracy is 0.99, which is close to 100%. Again, this is a sample data set or a test data set. In real world use cases, you might get different numbers for the accuracy. Let's go to the prediction part. They want to predict the number of original versus counterfeit banknotes. I'm using the same function that was created by the create model, and I'm passing the same columns as the input. I have a small case statement. When I see a predicted is 0, it's the original banknote, and while if the predicted is 1, it's a counterfeit banknote. Let's run it. So it predicted in our data set, there are 310 original banknotes and there are 213 counterfeit banknotes. We'll move on to the next part of the workshop, which is bring your own model inference in Redshift ML. In the previous use case, we saw advanced data scientists using XGBoost algorithm in Redshift ML. There are more algorithms very specific to different use cases, which might not be available in Redshift ML yet. In this situation, the advanced data scientists might want to run the create model in SageMaker and then bring the trained model into Redshift ML to run inference queries on a large data set or data set at scale, right? This enables data scientists to use the computing power of Redshift and run inference queries at scale. For this workshop, we will use the random cut forest algorithm to detect anomalies in a data set. At this point of time, RCF or random cut forest algorithm is not available directly in Redshift ML to use. So our data scientist decides to create the model in Amazon SageMaker and then import the trained model into Redshift ML. For this dataset, we will use the NYC taxi dataset, which records the amount of New York City taxi ridership over the course of 6 months. So we will then use this model to predict anomalous data points by emitting an anomaly score for each data point. So this notebook mainly focuses on how to create a random cut forest train model in Amazon SageMaker. It has all the detailed steps. So we will touch upon the relevant points because our focus is more about bringing the train model into Redshift ML. So let's set the Redshift parameters that are required to run this create model, which is the Redshift endpoint, the Redshift user to use, and the Redshift IAM role, and the SageMaker S3 bucket. This cell does a check on the S3 bucket to see if we have access to the data that we want to download or use in the training. This cell as loads the NYC taxi dataset into a pandas data frame. I will show you how the data looks like. This is already here, but I'll just run it again. This is how the dataset looks like. Basically, it has a timestamp value and the ridership, the count of the riders for that particular timestamp. Let us also plot this dataset to get a better visual. By looking at the data here, we can see some anomalous, uncharacteristic spikes, especially at data point 6000. Yeah, let's zoom in this specific area to get a better picture. This is how the dataset looks like when you zoom into this specific area. As you can see, there are some uncharacteristic spikes here in the data. And this is how the data looks like where we saw the spikes. So there are some uneven numbers here compared to the other other timestamp numbers here. This talks about how to create SageMaker RCF training job. I already ran this because it takes time and so a trained random cut forest model does nothing on its own. So we want to create a reference endpoint so that we can use this trained model on a dataset to see the anomalies. So this command actually deploys the trained model into an RCF random cut forest inference endpoint. Again, I have already created the endpoint, keeping the duration of this workshop. This is the random cut forest endpoint. So now we can pass the inference dataset either as a CSV or a JSON format. I'm going to set the CSV serializer and the JSON deserializer. So let's pass the first 6 values to the inference endpoint just to get an idea. This is how the inference looks like. But what we're looking for is the anomaly scores, right? Like I mentioned before. So what the random cut forest does is it assigns the anomaly score to each of the data point. So let's run that. So as you can see here, for each of the data point, the trained model assigned a score to it, and we are particularly interested. We are particularly interested in the scores that are greater than 3 standard deviations from the mean score, which we will consider as anomaly for this exercise. So we are particularly interested in anomaly values more than 3 standard deviations from the mean score. Let's run that. So you can see the scores, the anomaly scores assigned each of the data point. And the following is the list of known anomalies that happened during this time frame. So there was an NYC New York City Marathon that happened, with New Year's Eve and a snowstorm. Let's plot this anomaly score, and the ones that are highlighted here is the one with the anomaly score of more than 3. Okay, so far, whatever we have seen is happening in Amazon SageMaker. This is our advanced data scientist who created the model, random pet forest model. Now, he also ran some inference tests on small data sets. Now, the actual use case of Redshift ML comes into picture. Now, he wants to import this trained model into Redshift and run inference on a large data set. So, how you can do that? Again, remember we ran the run SQL command, which is the data API, which creates the connection to the Redshift cluster. We are going to do that now. And here is the taxi dataset is created as a table in Redshift, and it's also loaded using the copy command. It's already preloaded, but if you want to create, here is the DDL for that. So here, if you hit this cell, it's going to create the table and load the data from this public bucket. So we already know the inference endpoint, which is this from the previous steps. And I'm going to use that hard-coded here just for the workshop purpose. If you look at the create model statement here, it's very similar to the previous create model statement that we used before. The only difference here is we are providing a SageMaker inference endpoint, which is I've hard-coded it here for the workshop purposes. And I'm going to change the name of the create model function because I already have the pre-built models. Let's run this. While the new create model is running, I will show you the show model for the pre-built model that I already created. Okay, it gives the model name, the owner of the model, and the model state is already ready because it was already created before, and the endpoint that we imported from Amazon SageMaker, and the function name. Let's run the show model for the one that we just kicked off. So this is also ready. We can use it actually in our inference. Because the model was already created in SageMaker, this create model is very quick. So let's compute and plot the anomaly scores for the entire data set. I'm using the table that we created before. And the function that got created out of the create model that we ran above. Actually, this is from the pre-built model that I created. So as you can see here, again, so Redshift ML created the scores for each of the data point. And we are only interested in the data points where the anomaly scores is greater than 3 standard deviations from the main score. So let's run that. I'm using the same remote function here, and I'm using the standard deviation function on top of it. The inference query is complete now, and we can see we have the scores, anomaly scores attached to each of the timestamp, and also the ones that are greater than 3. So you can also see these scores are very comparable and close to the ones SageMaker predicted up here. Right here. That brings us to the end of this workshop. In this, we saw how an advanced data scientist can use the auto off feature in the create model command and use algorithm like XGBoost, and also how you can train a model in Amazon SageMaker and bring it inside Redshift ML using a bring your own model create model command. Back to you, Phil. Thank you.
Hi, everyone. Thanks for joining our webinar today. Satish and I will now be available to take questions.